Welcome to another episode of The Angry Old Goat. Let's talk about buying a used sniper. Is it a gamble? Absolutely. Can it be worth the money? Yeah, it depends. Refurb units go for $1,000. New unit goes for $1,600. I'm just throwing numbers out there, guessing, approximate. On the Goat, we have the Rochester Quadrajet. I'm not saying they don't, but I've yet to see one come up as a refurb unit. Even find them used is hit and miss. So we found one recently used. It was claimed to have been repaired by Holley recently. Price was pretty decent. Even if we have to send it to Holley to be repaired, it'll still come out cheaper than buying a new one. So we went ahead, pulled the trigger, and got it. Got the handheld, and we've got the Sniper Quadrajet. Wiring all looks decent. Can connection, temperature, coolant temperature, O2 sensor, 7-pin and the 10-pin. Thing is beautifully clean. Some modifications done to the linkage. Nothing we can't work around. Actually won't impact us at all. Pretty decent looking unit. Can we say for sure it's been repaired by Holley? I'll take the guy's word for it. We test a lot of these. Or if you drive a lot with one of these, breakout harness makes testing real easy. We can connect this to the, find it again, seven-pin connector, and in that 7-pin we have power, ground, ignition on, distributor input. This then would connect to the wiring on the body, and we now have a very convenient place to do any testing on a car. Highly recommend making one. I'll provide the part numbers if you're interested in making one. This is actually couple of horses I've accumulated playing with different ones, and another connector I purchased. And if you're really serious about playing with these things, power supply cable, 7-pin connector, relay fuse. This is all off the Holley harness. We connect this directly to our power supply. Provides us our ignition on circuit, and can verify fuel pumps working. And on that note, we'll use our test light here to reference if the fuel pump is indeed working. Have our ignition on circuit available. Makes for very clean hookup on testing. And connect our handheld to our can signal. So, now we need cool temperature and an oxygen sensor. We just happen to have a couple used parts. ignition sensor. Coolant temperature. And we'll get to the 10 pin in a minute. Right now, let's see if statically this thing works. So, we'll turn on our power supply. And verify we have power, 14 volts. Verify we've got continuity to ground. Continuity to ground, no voltage present on the ground. So at this moment, we're ready to turn this unit on. We should be able to verify it came on by watching the handheld. Stand up so you can see it, or I'll hold it. And as we turn it on, we should also see fuel pump cycle. Pink wires are key on, green being reference to switch. Handheld's powering up, fuel pump is cycling, fuel pump shut off, handheld's on. So for all intentional purposes, this unit is on now. And right off the bat, the handheld doesn't do anything. So, we'll turn the unit back off. Right off the bat, that's garbage. We do know we have a good handheld in the goat. That key back on, powering up, fuel pump is cycling, fuel pump's off, and we have a data display. The handheld usually remembers the last screen you were on. The reason we went there. Map pressure, 103 kPa, so we're referencing atmospheric pressure. O2 sensors initializing. Yes, it is heating up. Intake air and coolant temperature should be about the same. About 20-degree difference. This is one of the Holley sensors. We know there is a difference in those, so I'm not too concerned about that. So the manifold air temperature says it's 72 degrees. This says we're 90 degrees. And I believe we're about 73, 74 degrees out here right now. So for all intentional purposes, we are good. So the next point we're going to test, do the injectors fire? And most importantly, is the white wire on the 10 pin actually trigger our ignition system? Let me get that set up for you and we'll be right back. Alright, so we've got our ignition set up. I don't have a connector made for this yet, so we've got some jump wires in place. We have crank signal high, signal ground, power or ignition on to our distributor. So we're using a dual sync in this example. We're connected to the brown wire on that 10 pin, set our meter in frequency. That should then give us a correlation to RPM. Turn the system on. As we rotate our distributor, we should hear the injector's pulse. We should see an RPM signal. And we should also see a frequency correlating to that. And indeed we do. So the next thing we want to check is the white wire. This is going to be our signal to trigger our ignition box. It should switch to ground. For example, test the CD box, you touch the white wire to ground, that causes a spark. Right now, meter, we're showing resistance to ground. It's an open circuit. Doesn't bode well. I've turned it a couple times by hand. I can hear the injectors pulsing. The meter still says OL. But for argument's sake, let's give it some RPM. We have no switching to ground. So unfortunately, at this point, we can determine, or we know, that the ECU on this sniper, which is located right here on the side, does not switch the white wire to trigger the CD box to fire our ignition system. So at this point, we'll contact Holley and see about possibly getting an ECU replacement. And we'll do that in a future update. Thank you for joining us.